Close your eyes. Feel the weight of your body settle. Let the present moment fade away. Now, step backward through time. Not years, not centuries, but thousands of years. Keep going, further, deeper into the past. Millions of years dissolve like mist. You are standing somewhere you have never been. Somewhere no modern human has stood in living memory. Open your eyes. You are on the floor of a shallow sea, 430 million years ago. The water here is warm, roughly 30 degrees Celsius, wrapping around you like a heavy blanket. Above, the sun is distorted by the ripples of a saline ocean that stretches across the entire horizon. There is no ice at the poles. There are no birds in the sky. The silence here is profound, broken only by the slow rhythmic pulse of the tides against ancient reefs. Look closer at the seabed. This is not a barren wasteland. It is teeming with life forms that defy imagination. A pterygotus, a massive sea scorpion measuring 2.5 meters in length, glides silently through the water column, its paddle-like limbs pushing it forward with terrifying grace. Its compound eyes scan the sediment for prey. It is the apex predator of this world, a king in an ocean of invertebrates. Near your feet, armored fish known as placoderms root through the mud. They are the first of their kind, primitive jawed vertebrates that will one day give rise to the lineage that leads to us. Above them, colonies of graptolites drift like biological lace, filtering nutrients from water that is rich in carbon dioxide. Concentrations here are nearly 4,500 parts per million, creating a greenhouse effect that keeps the planet sweltering. This is the Silurian period. It is a world of water, of heat, and of slow, grinding evolution. It feels alien, it feels distant, but it is Earth. This is your home, deep in its own memory. As you watch the sea scorpion turn and vanish into the gloom of the deep water, a thought begins to form. A question that is both simple and unsettling. We look at this ancient world and see only nature. We see fossils, we see rock layers, we see a history of dumb beasts struggling to survive. But we are looking through a keyhole. The window of time that preserves fossils is incredibly small. We see perhaps one bone for every billion animals that ever lived. The rest is gone, turned to dust, subducted into the mantle, erased. Now imagine time not as a line, but as a vast, dark ocean. We are floating on the surface, confident that we are the only ship that has ever sailed these waters. But what if, deep below, in the abyss of hundreds of millions of years, other ships have sailed before us? What if another civilization rose, built cities, burned fuel, and reached for the stars, only to decline and vanish 300 million years before the first dinosaur drew breath? Would we know? If an industrial society existed for 100,000 years, a blip in geological time, would any trace remain after 400 million years of erosion, volcanic activity, and continental drift? Or would the slate be wiped clean? The sunlight filters down through the green water. The reefs of tabulate coral stand silent. They keep their secrets well. We assume we are the first to think, to build, to dream. We call ourselves the masters of this planet. But the Earth is old, so very old. And it has a long memory that we have barely begun to read. Look at the sediment settling on the ocean floor, grain by grain, layer by layer, covering the dead, hiding the past. What lies beneath that next layer of shale? Is it just more biology, or is it technology? But here is the question that will follow us through this documentary. What if we are not the first? What if, buried beneath hundreds of millions of years of stone and sediment, there lies evidence of something we have refused to see? This is not just a story about rocks. It is a story about hubris. It is a journey into the deepest shadows of our planet's history to ask if we are truly alone in time. The answers may be waiting in the stones beneath your feet right now. waiting for someone to finally ask the right question. The sea scorpion returns, a shadow in the murky water. It ruled this world for millions of years. We have ruled for mere thousands. Who is to say what happened in the silence between? Let us descend further. Let us peel back the layers of the earth and look for the ghosts of civilizations that time forgot. The journey is long, the evidence is scattered. But the possibility changes everything. If you enjoy journeys like this one, consider subscribing. There's much more waiting for you. Before we drift further into the dream of what might be, we must ground ourselves in what we know. This idea that a civilization could have existed before humans sounds like science fiction. It sounds like a story told around a campfire, whispered in the dark to frighten children. But in 2018, it became something else entirely. It became a serious scientific question, posed by credentialed researchers, published in peer-reviewed journals, and discussed in the quiet halls of NASA. The question was posed not by conspiracy theorists or fringe academics, but by two respected scientists working at the cutting edge of climate science and astrophysics. Dr. Gavin Schmidt, the director of the NASA Goddard Institute for Space Studies, one of the world's leading centers for climate modeling, and Adam Frank, a professor of astrophysics at the University of Rochester, whose work focuses on the life cycles of stars and the possibility of life on other worlds. They were not looking for aliens. They were not chasing myths. They were looking at climate change, the most pressing issue of our time, and asking a question that turned out to be far more profound than either of them expected. Dr. Frank was visiting NASA's Goddard Institute to discuss the climates of exoplanets, distant worlds orbiting other stars. He was interested in the idea of the Anthropocene, the proposed geological epoch defined by the measurable impact of human activity on Earth's geology and ecosystems. The term was popularized in the year 2000 by atmospheric chemist Paul Crutzen, who argued that humanity had become a geological force, reshaping the planet's surface, atmosphere, and biosphere in ways that would be visible in the rock record for millions of years to come. Dr. Frank wondered, if we look at other planets through telescopes, examining their atmospheric compositions and temperature records, how would we know if a civilization had once altered their climate? What would be the telltale signs? What would survive the passage of time? It was a theoretical exercise, a way to sharpen the tools we might use to search for extraterrestrial intelligence. But Dr. Schmidt, sitting across the table, paused. He leaned back in his chair and asked a simpler, more provocative question. How do we know we're the only time it's happened on Earth? The room went quiet. It was a question that neither of them had seriously considered before. Could there have been an industrial civilization on Earth before humanity? Not just intelligent animals, but a society that mined resources, built cities, and fundamentally altered the chemistry of the planet. And if such a civilization had existed, say, 100 million years ago, would we even know? This conversation, which began as a thought experiment over coffee, led to a formal collaboration. Together, Schmidt and Frank spent months researching the question, diving deep into the geological record, consulting with paleontologists, stratigraphers, and geochemists. The result was a peer-reviewed paper, published in April 2018 in the International Journal of Astrobiology by Cambridge University Press. They titled it The Silurian Hypothesis. Would it be possible to detect an industrial civilization in the geological record? The name was a playful nod to a specific episode of the long-running British science fiction series Doctor Who, which aired in 1970. In that episode, titled Doctor Who and the Silurians, the Doctor discovers a race of intelligent reptiles called Silurians who claim to have ruled the Earth millions of years before humans evolved. They built a technologically advanced civilization, but when a rogue planet threatened to collide with Earth, they retreated into underground hibernation chambers, planning to wake once the danger passed. The planet turned out to be the Moon, captured by Earth's gravity, and the Silurians slept for millions of years while mammals rose to dominance on the surface. The name Silurian in the show was actually a misnomer. The writers intended to reference creatures from the Silurian period, but later episodes clarified they were actually from the earlier Eocene epoch. Nonetheless, the name stuck. Schmidt and Frank chose it not as a claim that reptiles built cities, but as a cultural reference point, a way to make the question memorable. But the science within the paper was anything but fiction. The paper addresses a fundamental problem in geology and paleontology: the incompleteness of the fossil record. We often believe, almost instinctively, that if a creature existed, we would find its bones. Museums are filled with skeletons, dinosaurs, mammoths, ancient hominids, and this creates an illusion of completeness. But fossilization is an incredibly rare event, a statistical miracle that requires a precise confluence of conditions. An animal must die in exactly the right place, usually underwater or in a swamp where oxygen is scarce. It must be buried quickly before scavengers tear it apart or bacteria decompose it. So the sediment must be fine-grained like mud or volcanic ash to preserve delicate structures. Then, over millions of years, the organic material must be replaced by minerals without disturbing the shape, a process called permineralization. Finally, the rock containing the fossil must be uplifted by tectonic forces and eroded in just the right way to expose the fossil without destroying it. The odds of all these events happening are vanishingly small. Studies estimate that fewer than 1% of all species that have ever lived are represented in the fossil record. For many species, we have only a handful of specimens. The entire fossil record of early hominids, our direct ancestors, consists of perhaps a few thousand individuals spread across 6 million years. If you do the math, that is roughly one fossil for every 100,000 years of history, representing a population that may have numbered in the millions at any given time. The sample size is absurdly small. Now, imagine a civilization that existed for only 10,000 years, the same span as our own recorded history from the first Sumerian cities to the present day. If that civilization arose and fell 100 million years ago, the chances of finding a direct fossil, a skeleton holding a tool or a body buried with artifacts, are statistically close to zero. The individuals of that civilization, even if there were billions of them, might leave no recognizable remains at all. Bones dissolve in acidic soil. Bodies are consumed by scavengers, cremation, burial at sea, or simply dying in environments where sedimentation does not occur would remove all trace of them. Our entire species could vanish from the record, leaving only the faintest chemical whisper. So Schmidt and Frank proposed a different method of detection. They argued that we shouldn't look for bones or ruined cities or artifacts. We should look for chemical fingerprints, anomalies in the rock layers that indicate a sudden, unnatural change in the Earth's systems. When a civilization builds an industrial society, it changes the chemistry of the planet in measurable ways. It burns carbon, releasing ancient stores of CO2 trapped in coal and oil. It smelts metals, creating pollution layers of lead, copper, and mercury. It synthesizes materials that do not exist in nature: plastics, concrete, synthetic isotopes. These leave traces that can persist far longer than stone or steel. Consider our own civilization as a case study. Since the Industrial Revolution began roughly 250 years ago in the mid-18th century, we have released massive amounts of carbon dioxide into the atmosphere. This carbon doesn't just vanish into thin air. It is absorbed by the oceans, where it dissolves and changes the pH, making the water more acidic. It is taken up by plants during photosynthesis, then locked into the wood and soil. Eventually, over thousands and millions of years, this carbon settles into the sediment at the bottom of lakes and oceans, where it is compressed into rock. Future geologists examining core samples 10 or 50 million years from now would see a sharp spike in carbon isotopes, a sudden release of light carbon-12 from burning fossil fuels, which have a distinct isotopic signature compared to carbon released by volcanoes or natural organic decay. This is known as a carbon isotope excursion, and it would be visible as an anomaly in the sedimentary layers. We have also blanketed the Earth in plutonium-239, a radioactive isotope that does not exist naturally in significant quantities. Plutonium-239 is a product of nuclear fission created in reactors and released during the atmospheric nuclear weapons tests conducted between 1945 and 1963. More than 500 nuclear bombs were detonated above ground during this period, scattering radioactive fallout across the globe. Plutonium-239 has a half-life of 24,100 years, meaning that even after 100 million years, sensitive instruments might still detect the decay products of this sudden, unnatural layer. It would appear as a thin, globally distributed spike of radioactivity, sandwiched between layers of otherwise natural rock. Then there are the plastics. Synthetic polymers, polyethylene, polystyrene, PVC, that do not degrade like natural materials such as wood or bone. Since the mass production of plastics began in the 1950s, we have produced over 8 billion metric tons of plastic waste, much of which has ended up in the oceans. Plastics break down into microparticles and nanoplastics, which are now found in the deepest ocean trenches, in Arctic ice, and in the bodies of virtually every marine organism. Over millions of years, heat and pressure from burial under sediment might crush these microplastics into a thin, distinct layer of synthetic carbon, a technofossil or technosignature embedded in the rock. It would be chemically distinct from any natural material, a marker of industrial activity as clear as a neon sign. So the Silurian hypothesis asks a deceptively simple question. Do we see these signatures in the deep past? Have geologists already found layers that resemble the chemical fingerprint of an industrial civilization, but attributed them to natural causes? The answer is complicated. The Earth's history is full of dramatic, catastrophic events that can mimic the effects of civilization. Volcanic eruptions can release enormous amounts of CO2. Asteroid impacts can vaporize rock and create global layers of iridium and soot. Natural nuclear reactors, like the one discovered at Oklo in Gabon, can produce plutonium through spontaneous fission. The most famous candidate for a natural analog to our current situation occurred 56 million years ago during an event called the Paleocene-Eocene Thermal Maximum, or PETM. This event marks the boundary between two geological epochs, the Paleocene and the Eocene, and it represents one of the most dramatic climate shifts in Earth's recent history. During the PETM, the Earth's temperature spiked by 5 to 8 degrees Celsius in a very short geological window, perhaps as little as a few thousand years, possibly even faster. This warming was driven by a massive release of carbon into the atmosphere, estimated at 2,000 to 7,000 gigatons, comparable in scale to the amount of carbon we are releasing today through fossil fuel combustion. The carbon isotope ratio in the rocks from that time swings wildly. Scientists measure this using the ratio of carbon-12 to carbon-13. Organic carbon, carbon that comes from living things or from the breakdown of organic matter, is enriched in the lighter isotope, carbon-12. During the PETM, the ratio shifts dramatically, indicating a sudden influx of organic carbon into the atmosphere. The signal looks very similar to the one we are creating today by burning coal, oil, and natural gas, which are themselves ancient organic carbon. The cause of the PETM is usually attributed to one of two natural mechanisms. The first is massive volcanic eruptions. Around the same time, the North Atlantic Igneous Province, a vast region of volcanic activity stretching from Greenland to Scotland, was erupting, releasing huge volumes of CO2. The second theory involves the release of frozen methane hydrates from the ocean floor. Methane is a powerful greenhouse gas, and during the PETM, warming oceans may have triggered the release of methane trapped in ice-like structures on the seafloor, creating a runaway feedback loop. Gavin Schmidt and Frank pointed out a troubling possibility. If an industrial civilization had caused the PETM, the chemical signature might look almost identical to these natural explanations. A civilization burning fossil fuels or even deliberately releasing methane would produce the same isotopic signature. The sudden warming, the mass extinction of deep-sea organisms, the acidification of the oceans, all of it could be explained by either nature or intelligence. This is the crux of the problem. Nature is violent and capable of extreme changes. The Earth has experienced at least 5 major mass extinction events in the past 500 million years, each erasing more than 75% of all species. Volcanic eruptions have buried entire continents in ash. Asteroid impacts have vaporized mountains. Ice ages have locked the planet in glaciers. And greenhouse periods have turned the poles into swamps. Distinguishing between a natural catastrophe and an artificial one after 50 million years is incredibly difficult. The tools we use, isotope ratios, sediment layers, fossil distributions, can only tell us so much. Furthermore, erosion wipes away surface features. Wind, rain, and glaciers grind mountains into sand. Rivers carve valleys and deposit sediment over old landscapes. Plate tectonics recycles the ocean floor. Most of the oceanic crust is less than 200 million years old, meaning anything built on the seafloor before that time has been subducted into the mantle and melted. If a civilization lived on a continent that has since been pushed under another plate, like the ancient Tethys Ocean, now closed by the collision of Africa and Eurasia, their entire history has been erased. They melted back into the Earth's liquid interior. It is gone forever, beyond the reach of archaeology or geology. The International Commission on Stratigraphy, the scientific body responsible for defining the geological timescale, defines the actual Silurian period as lasting from 443.8 to 419.2 million years ago. That is a span of nearly 25 million years. To put that in perspective, the entirety of human history, from the first stone tools crafted by Homo habilis 3 million years ago to the Apollo moon landing in 1969, fits into a window of roughly 3 million years. Complex human civilization, cities, writing, agriculture, metalworking, is less than 10,000 years old, a blink of an eye in geological terms. In the span of the Silurian alone, a human-level civilization could have risen, flourished, and fallen 500 times over, and without any of them overlapping. The gaps in the rock record, periods where no fossils are preserved, where sediment was not deposited, or where it was later eroded away, are often longer than the entire duration of our species' existence. There are missing chapters in Earth's history, blank pages where anything could have happened and we would never know. We are dealing with deep time. Time so vast it crushes the mind and warps intuition. Geologists often use the metaphor of compressing Earth's history into a single 24-hour day. In this analogy, the Earth forms at midnight. The first life appears around 4 a.m. Complex multicellular organisms don't show up until 8 p.m. Dinosaurs walk the Earth from 11 p.m. to 11:40 p.m. All of human history, from the first stone tools to the internet, occurs in the last 2 seconds before midnight. A civilization that lasted 10,000 years and vanished 100 million years ago would be a flicker of a microsecond lost in the noise. We look for a needle in a haystack, but the haystack has been burned, scattered by wind, buried under a mountain, and then crushed into coal. And yet, the markers, the isotopes, the odd layers of metal, the sudden extinctions, they are there. We usually explain them away as volcanoes or asteroids, and usually we are right. Nature is more than capable of producing these anomalies without any help from intelligence. But science requires us to ask, are we sure? Have we looked closely enough? Have we asked the right questions? As Dr. Schmidt noted in an interview after the paper's publication, you can't find what you don't look for. If we assume, a priori, that humans are the only intelligence ever to arise on Earth, we will interpret every anomaly as a natural event. Our models, our theories, our entire framework of understanding is built on that assumption. But if we open our minds to the possibility of the Silurian hypothesis, not as a certainty but as a testable scientific question, the anomalies begin to look different. They begin to look like something else. They begin to look like ghosts. So, let us look. Let us return to the ancient Earth, not as tourists marveling at fossils, but as detectives searching for clues. Let us walk the beaches of the Silurian world and listen to the wind whistling through the primitive plants. Let us dig into the sediment and examine the chemistry with fresh eyes. Is it truly empty? Or are we just deaf to the echoes of what came before? The answer may be waiting in the rocks beneath our feet, patient and silent, ready to be uncovered by those brave enough to ask the question. Let us reconstruct the stage upon which this mystery plays out. To understand what might be hidden, we must first understand what was clearly there. The Earth of the Silurian period is a planet both familiar and utterly strange. If you were orbiting above it in some impossible spacecraft, looking down through the thin veil of atmosphere, you would not recognize the continents. The grand land masses we know, Africa, Asia, the Americas, are fragmented, drifting in a slow tectonic dance that has been choreographed over hundreds of millions of years. The map of this world is a puzzle with pieces scattered across a blue canvas. To the south lies the supercontinent of Gondwana, a colossal landmass comprising what will one day be South America, Africa, Antarctica, Australia, and India. It is a titan among continents, covering nearly 100 million square kilometers, roughly the size of Asia and Africa combined in our modern world. It stretches over the South Pole, creating a vast, cold hinterland where ice still clings to the highlands, though the massive glaciers of the previous Ordovician age have largely melted, their meltwater flooding the low-lying plains and creating vast inland seas. The interior of Gondwana is a wilderness of red desert and ancient mountain ranges, worn smooth by eons of wind and rain. To the north, straddling the equator like stepping stones across a vast ocean, lie the smaller continents of Laurentia and Baltica. Laurentia is the core of what will become North America. It was a crescent-shaped landmass oriented east-west. Baltica, comprising the future Scandinavia and Eastern Europe, drifts slowly toward it. These two continents are destined to collide in a slow-motion crash that will take tens of millions of years, closing the Iapetus Ocean that separates them. This collision will raise the Caledonian Mountains, a range that once rivaled the Himalayas but has since been worn down to the gentle hills of Scotland and Norway. Between them, smaller fragments, Avalonia, Siberia, and others, spin like isolated islands in the planetary sea. The most striking feature of the Silurian Earth is the sea level. Because of the lack of polar ice caps and the thermal expansion of warm ocean water, sea level is extraordinarily high, perhaps 100 to 150 meters higher than today. Much of the continental land is flooded. Vast, shallow tropical seas, known as epicontinental seas, cover what is now the American Midwest, the Sahara Desert, Central Europe, and much of Siberia. These are not deep oceans, but sunlit lagoons and shelves where the water is rarely more than 50 to 100 meters deep. They are warm, sunlit, and rich in calcium carbonate dissolved from the limestone bedrock. They are the perfect cradle for life, a nursery for the explosion of biodiversity that defines this age. Descend into these waters again. Let the surface close over your head. The world beneath is a kaleidoscope of color and form, though not in the way we would recognize from modern coral reefs. The Flaw is a mosaic of primitive reefs built not by the scleractinian corals of today, but by their distant ancestors, tabulate and rugose corals. Tabulate corals form flat, honeycomb structures, are their tiny polyps living in interconnected tubes. Rugose corals, also called horn corals, grow as solitary cones or branching clusters, each polyp building its own calcium carbonate fortress. These structures are cemented together by stromatoporoids, layered, dome-shaped sponges that act as the mortar of the reef, binding it into a solid mass. The colors are muted compared to the electric blues and pinks of modern reefs. Here, the palette is earthy, ochres, pale greens, rusty reds, and creamy whites. But the shapes are fantastic, alien. The reef rises in terraces and arches, creating caves and canyons where shadows pool. It is a submerged cathedral of stone, built grain by billions of tiny organisms over thousands of years. The texture is rough under your fingers, encrusted with bryozoans, colonial animals that form lacy, fern-like patterns, and crinoids or sea lilies that wave their feathery arms in the gentle current. Swimming through these limestone towers are the nautiloids, shelled relatives of the modern squid and octopus. They are the jet-propelled predators of the Silurian seas. Some species, like Orthoceras, have straight, cone-like shells that can reach lengths of 3 to 4 meters, taller than a human. These shells are divided into gas-filled chambers, allowing the animal to control its buoyancy with precision. The nautiloid itself lives in the largest chamber at the open end, its tentacles, dozens of them, smooth and muscular, reaching out to grasp fish and trilobites. They are intelligent hunters with large, complex eyes that can form images. They are, perhaps, the smartest creatures of their time, capable of learning and memory. But they are not the masters of this world. That title belongs to the Eurypterids, the sea scorpions. These are arthropods, distant relatives of modern scorpions and horseshoe crabs, but adapted for an aquatic existence. Imagine a creature armored like a tank, segmented and plated with the agility of a predator. Jacalopterus rhenanii is the giant of giants, the largest known arthropod ever to have lived, growing up to 2.5 meters long, nearly the length of a small car. Its body is streamlined, built for sudden bursts of speed. Its claws, or chelicerae, are serrated and powerful, capable of snapping the spine of a fish or crushing the shell of a trilobite. It lies in wait in the brackish lagoons where rivers meet the sea, a monster in the mud, its compound eyes scanning the murky water for movement. Its smaller cousin, Eurypterus remipes, is more common, perhaps 50 to 100 centimeters long. These scuttle along the bottom in great swarms, their paddle-like tails propelling them in jerky, unpredictable movements. They are scavengers and hunters, tearing apart the carcasses of dead fish, their mouthparts grinding and chewing. At night, the sea floor comes alive with their activity, a writhing carpet of armored bodies competing for scraps. They are the cleanup crew of the Silurian, but they are also opportunistic predators, capable of swarming and overwhelming prey larger than themselves. The fish here are strange to our eyes, primitive and experimental. The acanthodians, sometimes called spiny sharks, though they are not true sharks, are small, most no larger than a human hand. They bristle with defensive spines on their fins, making them difficult to swallow. They dart nervously among the corals, feeding on plankton and small invertebrates. Their bodies are covered in tiny, diamond-shaped scales that glitter in the filtered sunlight. They are the first fish with true jaws, a revolutionary adaptation that will change the course of vertebrate evolution. The placoderms are the armored giants of the fish world. Their heads and the front portions of their bodies are encased in thick, bony plates that interlock like medieval armor. Species like Climatius and Ischnacanthus patrol the reef edges, their jaws, simple shearing blades hinged like scissors, snapping at anything that moves. They look industrial, like biological machines built for a war of survival. Their eyes are small and set deep within the armor, peering out from behind protective ridges. They are slow but unstoppable, grinding through the food chain with brute force. Above, the surface of the water is broken by the gentle ripple of graptolites. These are colonial animals, zooplankton, that drift in vast, transparent clouds. Each colony is a delicate structure, often looking like hacksaw blades or tuning forks, with individual polyps living in tiny cups along a central stalk. They filter the water for microscopic algae and bacteria. They are so abundant that their carbonized remains will one day turn entire layers of shale black, creating the graptolite zones that geologists use to date Silurian rocks. They are the plankton of the Silurian, the base of a food web that supports this entire underwater empire. Swarms of them stretch for kilometers, turning the water a milky, translucent white. Beneath them, crawling over the rocks and sand, are the trilobites. These ancient arthropods, related to modern insects and crustaceans, have been around since the Cambrian explosion 500 million years ago, and they are still going strong. Species like dalmanites have elaborate, spiny exoskeletons and large, faceted eyes, some of the most advanced eyes in the animal kingdom, capable of seeing in all directions simultaneously. They scuttle across the bottom, scavenging and hunting, their antennae twitching as they search for food. Some trilobites can roll into a ball for protection, like modern pillbugs, their segmented bodies locking into a perfect sphere. Now, move toward the land. This is the great frontier, the next chapter in the story of life. For the first time in Earth's history, the continents are turning green. This is the great invasion. The moment when life leaves the water and begins the slow, tentative conquest of the land. It is a revolution that will take millions of years to complete, but it has begun. The plants are small, fragile pioneers, clinging to the wet edges of rivers and marshes, never venturing far from the water they still depend on for reproduction. Cooksonia is one of the first. It is a simple leafless stem branching into a Y shape, topped with spore cases that look like tiny bulbs. It stands only a few centimeters tall, barely reaching your ankle. It has no roots, only a rhizome, a horizontal stem that anchors it in the mud. It has no leaves, only a green stem that performs photosynthesis. It reproduces by releasing spores into the wind, a gamble that most will land somewhere inhospitable. But enough survive to spread the green carpet slowly outward from the water's edge. Bariguanathia, a lycophyte, is more complex. It has spiraling needle-like leaves that cover its stem, resembling a modern club moss. It can grow up to 1 meter tall, a giant compared to Cooksonia. Its roots, true roots, burrow into the soil, anchoring it firmly and drawing up water and nutrients. This is an innovation that will allow plants to move further inland, away from the constant moisture of the coast. Zosterophyllum and Sordonia join the chorus, each species experimenting with different strategies for survival on land. There are no trees, no forests, no flowers, no grasses. The interior of the continents is still a desolate, lifeless landscape of bare rock and red sand, scoured by winds that scream across the empty plains unimpeded by vegetation. Dust storms the size of continents sweep across Gondwana, turning the sky orange and burying the shorelines in layers of fine silt. But along the coastlines, along the river deltas and the edges of the inland seas, a green carpet is spreading. It is thin, patchy and fragile, but it is there. And with the plants come the first pioneers of the animal kingdom. Millipedes like Pneumodesmus newmani, discovered in Scotland and dated to the late Silurian, are the oldest known creatures to breathe air. They are small, only about 1 centimeter long, but they represent a monumental leap. They have spiracles, tiny holes along their sides that allow air to diffuse into their bodies. They scuttle among the rotting vegetation, feeding on the decaying stems of Cooksonia and the fungal mats that carpet the wet soil. They are the cleanup crew, the recyclers of nutrients. Primitive arachnids, distant ancestors of spiders and scorpions, spin the first webs, delicate silk traps strung between the stems of plants. They catch tiny springtails, collembola, primitive insects that feed on fungus and algae. These are the first terrestrial food webs, simple and fragile but functional. The predators are small, the prey smaller, but the foundations of the ecosystems that will one day cover the continents are being laid. The air here is thick and heavy, almost syrupy in its humidity. Carbon dioxide levels are estimated to be 4,000 to 5,000 parts per million, nearly 12 to 15 times higher than the pre-industrial modern world of 280 parts per million. This creates a powerful greenhouse effect. The temperature is uniformly hot, with average global temperatures estimated at 25 to 30 degrees Celsius, much warmer than today's average of 15 degrees Celsius. There are no ice caps. The poles are temperate, covered in shallow seas and tundra-like vegetation. The equator is a furnace, with daytime temperatures soaring above 40 degrees Celsius. Storms are violent and frequent, driven by the immense heat energy trapped in the thick atmosphere. Hypercanes, hurricanes of immense size, possibly reaching wind speeds of 300 kilometers per hour or more, batter the coasts of Laurentia and Baltica, churning the shallow seas and burying the delicate reefs in sudden deluges of mud and sand. These storms are so powerful they leave their mark in the rock record as tempestites, layers of chaotic jumbled sediment that tell of ancient violence. Geologists find fossilized corals torn from their bases and scattered across the sea floor, trilobite shells crushed and mixed with gravel, entire reef communities obliterated in a single event. The oxygen content of the atmosphere is still relatively low, perhaps 14 to 16% compared to today's 21%. This limits the size of terrestrial arthropods, which rely on passive diffusion of oxygen through their spiracles. But in the water, where oxygen is dissolved and more accessible, life can grow large. This is why the sea scorpions can reach monstrous sizes, while the land arthropods remain small. Stand on the shore of this Silurian world. Plant your feet in the wet, sticky mud where the tide has just receded. The sky above you is a hazy violet blue, thick with humidity and tinged with the orange dust of distant storms. The sun is slightly dimmer than in our time because it is younger. The sun gains luminosity as it ages, still beats down with a ferocity that would burn modern skin in minutes. The UV radiation is intense. There is no ozone layer yet to filter it, only the thick blanket of CO2 and water vapor. The smell is sulfurous and organic, the scent of rotting algae, tidal mud, and the faint tang of salt. There is a sweetness to it too, the smell of decaying plant matter beginning to form the first primitive soils. Listen carefully. There is no bird song. Birds will not evolve for another 200 million years. There is no buzz of bees. Flowering plants and their insect pollinators are still far in the future. There is no howl of mammals, no croak of frogs. The only sounds are the wind hissing through the Cooksonia stems, rattling them like dry bones, are the crash of waves against the distant reef and the skittering of 1,000 tiny legs over wet stones as the millipedes and springtails go about their business. It feels primitive. It feels empty of high intelligence, of consciousness, of anything we would recognize as civilization. But looks can be deceiving. The oceans are vast and deep. We know the shallow seas well because they leave abundant fossils. The warm, calm waters are perfect for preserving life. But the deep Panthalassic Ocean, the predecessor to the Pacific, that covers the rest of the globe, it is a mystery. Its floor has been entirely recycled by tectonic subduction over the past 400 million years. Every square meter of sea floor that existed in the Silurian deep ocean is gone, melted back into the mantle. We have no idea what lived there. We have no idea what might have built there in the eternal darkness of the abyssal plains beyond the reach of sunlight and fossilization. And time. Time is the missing variable. This Silurian world lasted for 24.6 million years, from 443.8 to 419.2 million years ago. Stand here in this single moment and try to grasp that span. Watch the sun set 8 billion times. That is how many days passed. Watch the continents inch closer, millimeter by millimeter, driven by the convection currents in the mantle. Watch the reefs rise and fall, built over millennia, destroyed in a single storm, rebuilt again. Watch entire species evolve, flourish, and go extinct. Their time on Earth measured in millions of years. In all that time, across all those millions of years, is it truly impossible that something else woke up? That somewhere, and in a secluded estuary where the rivers of Gondwana poured fresh water into a sheltered bay, or on an isolated continent in the Southern Ocean, a species, perhaps a descendant of the nautiloids, perhaps something we have no fossil record of, began to use tools, to build fires from volcanic vents, to look at the stars and wonder, as we do, if they were alone? The Silurian is not just a chapter in a textbook, a list of species and dates to memorize for an exam. It was a real, breathing, living world. It had days and nights, seasons driven by the tilt of the Earth's axis, storms and calms, tragedies and triumphs. Creatures loved, fought, starved, and thrived. Entire ecosystems rose and fell. It was alive in every sense of the word. And like all living things, it had secrets. Some secrets we have uncovered: the fossils, the rocks, the chemistry. But how many secrets remain buried? We are walking through a graveyard where the headstones have crumbled to sand, where the names have been worn away by wind and rain. We assume the graves are empty because we cannot see the bones. But absence of evidence is not evidence of absence. The silence of the Silurian is not the silence of nothingness. It is not the silence of an empty stage. It is the silence of the forgotten, the silence of stories that were never written down, the silence of a past so deep that even the Earth itself has nearly forgotten. We return now to the central question, the shadow that hangs over this entire journey, the question that should make us pause and reconsider everything we think we know about our place in time. What if the Silurian hypothesis is right? What if an industrial civilization actually rose during Earth's deep past, flourished for thousands of years, and then vanished so completely that we walk over their remains without ever knowing they were there? It does not have to be the sea scorpions of the Silurian, those armored giants that once ruled the shallow seas. It could have been a reptile in the Triassic, 250 million years ago, emerging from the ashes of the Great Dying, the Permian extinction that erased 96% of all marine species and 70% of terrestrial vertebrates. It could have been a small, nimble dinosaur in the Cretaceous, 100 million years ago, evolving intelligence in the shadow of the great sauropods. It could have been a mammal in the Paleocene, just after the dinosaurs died, seizing the opportunity of an empty world. The specific era matters less than the terrifying reality of the math, the cold calculation of probability stretched across the incomprehensible vastness of geological time. We are biased by our own experience, trapped in the prison of the present moment. We see our cities of concrete and glass, our highways of asphalt stretching to the horizon, our satellites orbiting silently in the void, and we think, this is permanent, this is undeniable, this will be here forever. But the Earth is not a museum. It is a machine designed to erase, to recycle, to consume its own history. It is a grinder that never stops. Water, wind, ice, and tectonic fire are constantly breaking down the surface, pulverizing mountains into sand, dissolving rocks into solution, and folding the crust back into the mantle where it is melted and reborn as fresh magma. I consider this sobering fact. The oldest large area of oceanic crust on Earth is only about 180 million years old, located in the Western Pacific. The oceanic plates are constantly being created at mid-ocean ridges and destroyed at subduction zones, pulled down beneath the continents where they are heated to 1,000 degrees Celsius and melted back into the mantle. The entire ocean floor is recycled every 200 million years or so. Anything built on the ocean floor before that time, cities, ports, cables, structures of any kind, has been shoved under the continental plates and melted into magma. It is physically gone, atomized, its constituent elements redistributed through volcanic eruptions. There is no wreckage to find. There is no archaeological site to excavate. It is simply erased. The oldest surface rocks on the continents are nearly 4 billion years old, but they are rare, tortured remnants, twisted by heat and pressure into metamorphic forms that bear little resemblance to their original state. These ancient shields, the cratons of Canada, Australia, and South Africa, have survived only because they are thick, stable, and geologically lucky. Most of the Earth's surface is constantly being paved over by layers of sediment, buried under volcanic ash, or eroded away by the relentless action of rivers, carving valleys and glaciers, grinding bedrock into flour. So, we must ask layered, uncomfortable questions that cut to the heart of our assumptions. How long would our own civilization remain detectable if we disappeared tomorrow? The answer is both disturbing and humbling. Our bridges, those engineering marvels of steel and concrete, would rust and collapse in a few centuries, perhaps 500 years for the largest structures. Our concrete buildings, reinforced with steel rebar, would crack as the metal oxidizes and expands, crumbling into gravel in a few thousand years. The pyramids of Egypt, built of solid limestone blocks, might last 100,000 years before weathering reduces them to shapeless mounds. Our plastic, which we think of as permanent, would degrade under UV radiation and microbial action into microscopic dust within 10,000 years in most environments, though some types might persist longer, buried in anaerobic sediments. After 10 million years, what is left? Perhaps a thin layer of odd chemical residue, a spike in carbon isotopes, a concentration of rare earth elements, a band of synthetic polymers compressed into a glossy seam. Perhaps a concentration of refined metals like aluminum, copper, and titanium in a sedimentary strata, their unnatural purity betraying an industrial origin. Perhaps, most likely, nothing that a casual observer would notice. A geologist drilling a core sample might see it as an unremarkable layer of shale, just another band of grey in a column of rock, and move on without a second glance. What survives 100 million years? Almost nothing structural. No statues standing proud against the sky. No books preserved in libraries. No hard drives. No photographs. No monuments. The very concept of ruins becomes meaningless at this timescale. Only the chemistry remains. The isotopes. Or the faint chemical fingerprints embedded in the rock. Anomalies so subtle they could easily be mistaken for natural variations. A spike in plutonium that might be a natural reactor or a nuclear waste repository. A layer of carbon-rich sediment that might be a coal seam or the compressed remains of 1 billion plastic bottles. Could evidence be hidden in plain sight? Have we already found it and dismissed it? When we dig up a layer of rock and find a sudden spike in global temperature preserved in the oxygen isotopes of ancient shells, or a mass extinction event where 75% of species vanish in a geological instant, or a thin layer of radioactive material sandwiched between limestone beds, we label it natural anomaly. We call it a volcanic event and point to flood basalts. We call it a meteor impact and search for iridium. We call it climate change and invoke Milankovitch cycles. Because that is what we know. That is what fits our models. But what if one of those anomalies, just one, was actually a war? What if one of those climate spikes was an ancient climate change disaster caused not by volcanoes or orbital mechanics, but by the runaway industrial emissions of a civilization that burned too much carbon and could not stop? This is the haunting power of the Silurian hypothesis. It doesn't require us to invent magical evidence or appeal to the supernatural. It asks us to look at the evidence we already have, the data sitting in our rock collections, the anomalies catalogued in our databases, and wonder if we are misinterpreting the story. It turns the familiar, comforting history of Earth, the narrative of steady progress from simple to complex, into a mystery novel where the last few pages are missing, or perhaps the first few chapters. We are reading a book that might be the sequel to a story we never knew existed, but here is where the story gets truly strange. This is not just theoretical. In 2014, researchers analyzing ancient rock samples from the Ediacaran period, long before the Silurian, roughly 550 million years ago, discovered something unexpected. They found anomalous carbon signatures that could not easily be explained by volcanic activity alone. The patterns resembled, in disturbing ways, the isotope ratios we would expect from industrial combustion. The ratio of carbon-12 to carbon-13 was skewed, suggesting a sudden massive injection of organic carbon into the atmosphere. The finding was published quietly, discussed in specialized geological journals, then largely forgotten. It was categorized as a Shuram excursion, a massive perturbation of the carbon cycle. The leading theory is the oxidation of a massive reservoir of organic matter, but the speed and scale of it remain a topic of fierce debate. It fits the data for a natural event, but it also fits the data for something else. Then there is the Oklo reactor in Gabon, Africa. In 1972, French physicists discovered that uranium deposits there had undergone self-sustaining nuclear fission about 1.7 billion years ago. The official explanation is that it was a natural nuclear reactor, a freak occurrence where groundwater concentrated uranium enough to start a chain reaction. It is the only known natural nuclear reactor in the universe. It operated for hundreds of thousands of years, producing plutonium and managing its own heat. It is scientifically plausible as a natural event, but it is also exactly what a buried, ancient nuclear waste storage facility might look like after nearly 2 billion years. These are the glitches in the matrix, the moments where the rock record stutters. We smooth them over with theories of volcanoes and groundwater, and perhaps that is all they are. But in the quiet of the night, when we look at the timeline of 4.5 billion years, we have to wonder, are these natural anomalies or are they the fingerprints of the lost? If this story is carrying you somewhere peaceful, feel free to close your eyes. The narration will guide you. Let us drift now into the realm of pure possibility, into the territory where science meets imagination and the boundaries blur. Let us construct a history that might have been a narrative woven from threads of fact and hypothesis. We will not look at the Silurian specifically, but cast our net wider into the vast ocean of time that stretches behind us. Imagine a species that evolved intelligence 100 million years ago during the Cretaceous period, a time when the Earth was warmer, the continents arranged differently, and the dinosaurs were the dominant life forms thundering across Pangaea's fragmenting remains. But in the shadows of the fern forests, beneath the canopy of ancient conifers and cycads, something else is waking up. Something that will change everything. Step 1 is the evolution of intelligence itself. This is not a sudden event, not a miraculous leap, but a slow burn that smolders across geological epochs. It takes primates roughly 60 million years to go from tree shrews scurrying in the undergrowth to humans contemplating the cosmos. Evolution does not rush. Let us imagine a lineage of small bipedal dinosaurs. Troodontids, perhaps, those fleet-footed predators with large eyes and grasping hands, already showing signs of advanced problem-solving. Fossils show they had brain-to-body ratios approaching those of modern birds, the highest among non-avian dinosaurs. They are social creatures hunting in coordinated packs, their survival depending on communication and cooperation. They begin to use stones to crack the shells of ancient mollusks and the eggs of other dinosaurs. At first, it is instinct, trial and error. But over generations, over 10 or 20 million years, their brains swell, folding in on themselves to create more surface area for neurons. The brain is expensive tissue, demanding 20% of the body's energy budget, but the advantage it confers, the ability to predict, to plan, to remember, is worth the cost. They develop proto-language, simple at first, warning calls, mating songs, but gradually becoming more complex, capable of conveying abstract concepts. They begin to coordinate hunts, not just with gestures, but with sounds that carry meaning. They tell each other where the prey is, what dangers lie ahead. They are not yet a civilization, not yet builders or artists, but they are no longer just animals. They have crossed an invisible threshold, entered the realm of self-awareness. Step 2 is the Stone Age equivalent, the first glimmers of culture and technology. For 1 million years, a span that dwarfs all of recorded human history, they live in tribes of 20 to 50 individuals, moving with the seasons, following the herds of giant sauropods whose carcasses feed them for weeks. They master fire, perhaps from a lightning strike preserved in a hollow tree, perhaps from observing volcanic vents. Fire changes everything. It extends the day, allowing them to work and socialize after dark. It cooks food, making nutrients more accessible and freeing energy for further brain growth. It wards off predators, the giant theropods that stalk the night. They build temporary shelters of wood and hide, frameworks lashed together with plant fibers, covered with the skins of prey. They begin to tell stories, myths of the stars and the seasons, creation tales of the first hunter and the sun. These stories are not written, they have no writing, but they are remembered, passed down through generations, shaping the culture. They leave stone tools scattered across the continents, but these are not elaborate artifacts. They are simple flakes, hand axes, scrapers, objects that serve a purpose and are then discarded. Stone tools, when buried in sediment and subjected to millions of years of pressure, river tumbling, and glacial grinding, look remarkably like simple rocks to the untrained eye. A geologist examining a 100-million-year-old riverbed might pick up a flint axe and see only a naturally fractured pebble, weathered smooth by the water, indistinguishable from the thousands of other stones surrounding it. Without context, without bones nearby, without a clearly intentional site, the evidence is invisible. We might have already found their tools and never known it. Step 3 is the agricultural revolution, the moment that accelerates everything. This is the inflection point, the transition from nomadic existence to settled civilization. Perhaps they learn to farm a native fungus that grows in the rotting wood of fallen cycads, a nutritious, protein-rich crop that can be cultivated in shaded groves. Or perhaps they domesticate a species of nutrient-rich fern, selecting over generations for larger fronds, sweeter sap, faster growth. Agriculture is not inevitable. It requires the right conditions, the right plants, the right climate stability. But once it begins, it is unstoppable. Their populations explode. Where once a tribe of 50 might sustain itself, now villages of 500 or 5,000 can thrive on the surplus of the harvest. They build permanent settlements of mud brick and timber, structures that can last for generations. They irrigate the land, digging canals to divert rivers, creating artificial wetlands where their crops flourish. They develop pottery to store grain, weaving to make cloth, metallurgy to smelt copper from the green stones they find in the highlands. This lasts for 10,000 years, perhaps longer, a golden age of stability and growth. But mud bricks dissolve in rain. Clay returns to the soil from which it came. Timber rots, consumed by fungi and insects, collapsing into the earth. The roots of the forests reclaim their fields, breaking apart the stone foundations, pulling the structures back into the wild. The traces of agriculture, subtle pollen spikes in the sediment, when indicating a sudden abundance of cultivated species, are easily confused with natural climate shifts, a warming period that favored those plants naturally. Without written records, without metal artifacts that resist decay, the evidence is circumstantial, ambiguous. Step 4 is the industrial age, the moment of transformation that compresses centuries of gradual change into a single explosive burst. This is the flashbulb moment, the singularity of acceleration. In a span of just 200 years, a heartbeat in geological time, barely a single layer in the sedimentary record, they discover the energy trapped in coal seams formed during the Carboniferous, 200 million years before their time, when the world was a swamp and giant insects ruled the air. They learned to burn this ancient carbon, to harness the heat, to drive machines. Steam engines pump water from mines, allowing them to dig deeper. Factories spring up, belching smoke into the sky, transforming raw materials into goods at a scale never before imagined. They pave their cities with concrete, a mixture of lime, volcanic ash, and water that hardens into artificial stone. They build aqueducts, bridges, towers that scrape the sky. They synthesize plastics from petroleum, creating materials that do not exist in nature, polymers that are lightweight, durable, and seemingly eternal. They split the atom, unlocking the power of the nucleus, building reactors that generate electricity and bombs that can level cities in an instant. Their population swells to billions, concentrated in vast urban centers where the night sky is drowned in artificial light. They send signals into space, radio waves carrying their voices to the stars. For a brief, brilliant moment, they are gods. And then, Step 5. The collapse. It comes in many possible forms, and the specific mechanism matters less than the inevitability. Perhaps they burned too much carbon too quickly, releasing trillions of tons of CO2 into the atmosphere, triggering a runaway greenhouse effect. The polar ice caps melt, sea levels rise 50 meters, drowning their coastal cities where most of the population lives. The weather becomes chaotic. Superstorms, droughts, floods. Crop failures lead to famine. Famine leads to war. Desperate nations fight over the last arable land, the last sources of fresh water. Or perhaps they fought a war with nuclear fire, a conflict that escalated beyond control. Thousands of warheads detonate within hours, each one a miniature sun. They're vaporizing cities, igniting firestorms that consume entire regions. The soot and ash blotted out the sun for years, triggering a nuclear winter. Temperatures plummeted, photosynthesis ceased, the food chain collapsed from the bottom up. Within a generation, 99% of the population was gone, the survivors scattered, their technological base shattered beyond recovery. Or perhaps, most intriguingly, they simply transcended. Perhaps their brightest minds realized that industrial growth was a trap, an exponential curve that could not be sustained on a finite planet. They saw the writing on the wall, the depleted resources, the poisoned rivers, the dying oceans, and made a collective decision to step back. They dismantled their factories, abandoned their cities, and returned to a low-impact equilibrium with nature, living in harmony with the planet rather than dominating it. Their descendants survived, but they carried no memory of the industrial age, only myths of a time when their ancestors commanded fire and metal. Whatever the cause, their high-energy civilization ends. The lights go out, the machines stop, the silence returns. Now, the Earth begins its work. The erasure begins, patient and thorough. 10 million years later, their cities are gone. Concrete, which we think of as permanent, is nothing more than a calcium-rich dust, indistinguishable from natural limestone deposits. Steel beams, once the skeletons of skyscrapers, have rusted into iron oxide stains in the soil, red bands that a geologist might attribute to ancient oxidation events. Glass, silica melted and reformed, has shattered and been ground by wind and water into sand grains, scattered across beaches mixed with natural quartz. The forests have returned, their roots cracking the last remnants of foundations, their canopy shading the scars of mines that have long since filled with sediment and debris. At 25 million years, the rivers have changed course, carving new valleys, burying old ones under alluvial deposits. The coastlines have shifted as sea levels fluctuate with the ice ages. Tectonic forces have uplifted old seabeds into mountain ranges, compressing the sediments, baking them with heat and pressure into metamorphic rock. Any structures built on these now mountains are crushed, their atoms rearranged, their original forms obliterated. The climate has cycled through warm periods and ice ages. Glaciers advancing and retreating, scouring the land, are depositing moraines of mixed sediment that bury everything. What would survive? What would be the techno-signature left behind, the fingerprint of intelligence pressed into the rock? First, look at the isotopes, the atomic fingerprints that do not lie. If they enriched uranium for weapons or power, they would have altered the natural ratio of U-235 to U-238. Natural uranium consists of 99.3%, U-238 and only 0.7%. U-235, enrichment concentrates the fissile. U-235, leaving behind depleted uranium with even less. U-235 than normal. This does not happen naturally. A deposit of uranium with a significantly depleted ratio is a smoking gun, a chemical anomaly that screams artificial. This is exactly what we found at Oklo in Gabon, where natural nuclear fission occurred 1.7 billion years ago. But the isotope ratios suggest conditions that are vanishingly rare. Could some of these natural reactors actually be ancient waste repositories? A civilization's nuclear waste, buried deep in stable granite formations far from tectonic activity, would remain a radioactive anomaly for billions of years. Plutonium-239, with its half-life of 24,100 years, would eventually decay, but its decay products, uranium-235, thorium, lead, would remain in unnatural concentrations. Even after 100 million years, sensitive mass spectrometry could detect the signature, a subtle distortion in the ratios that whispers of artificial manipulation. Second, look for the synthetic molecules, the compounds that nature never invented because they serve no evolutionary purpose. Some industrial chemicals, like perfluorocarbons, PFCs, and chlorofluorocarbons, CFCs, are incredibly stable. They are made of carbon, fluorine, and chlorine atoms bonded in configurations that do not occur naturally. In the environment, microbes cannot break them down. They lack the enzymes. UV radiation barely affects them. They persist. Even if the plastic bottles and packaging degrade over millions of years, broken down by heat and pressure into simpler hydrocarbons, the chemical bonds of these synthetic compounds might persist, trapped in the microscopic pores of sedimentary rock, absorbed into clay particles, locked into the crystal lattices of minerals. A future chemist analyzing a core sample from 100 million years ago with gas chromatography or mass spectrometry might find a molecule with a structure that does not fit any known natural process. A compound with fluorine atoms arranged in a way that only synthesis can produce. It would be a message in a bottle. A molecular fossil that says, "Intelligence was here. We made this." Third, look at the stratigraphy, the layering of the Earth itself. An industrial civilization moves dirt on an unimaginable scale. We humans are currently moving more sediment than all the world's rivers combined, an estimated 30 to 50 billion tons per year through mining, agriculture, and construction. We flatten mountains to extract coal and ore. We dig canals that reroute rivers. We create artificial deltas, dumping billions of tons of dredged material into the ocean. We build dams that trap sediment, altering the natural flow of material to the seas. This bioturbation on a massive scale disrupts the natural layering of the Earth. A geological layer that is chaotic, mixed, and filled with strange concentrations of nitrogen and phosphorus from synthetic fertilizers, heavy metals like lead and mercury, from industrial pollution, and anomalous spikes in sedimentation rate would be a sign. It would look like a sudden global disturbance, a moment when the planet's surface was churned and mixed by an unseen force. Geologists call similar events unconformities, gaps in the record where erosion or non-deposition occurred. But a global unconformity synchronized across multiple continents, filled with chemical anomalies. That would demand an explanation, and the simplest explanation might be civilization. But consider carefully what would not survive, what would be lost to the grinding wheels of deep time. Bones. We treasure our fossils, we build museums around them, but they are miracles of luck, rare exceptions to the rule of decay. If a civilization had 7 billion individuals but practiced cremation as a religious rite, or buried their dead in acidic rainforest soils where bones dissolve in decades, or simply died in places where sediment didn't accumulate rapidly enough to cover and preserve them, their fossil record could be effectively non-existent. We have found perhaps a few thousand hominid fossils to cover 6 million years of human evolution, representing a population that might have numbered in the tens of millions at any given time. That's a preservation rate of less than 0.0001%. If a species lived for only 100,000 years, a long time by human standards, but a single tick of the geological clock, we might never find a single tooth, a single bone fragment. Our entire species, with all our cities and art and literature, could fit into a geological gap in the Cretaceous strata that we simply haven't excavated. There are vast stretches of the Mesozoic where we have no fossils at all, not because nothing lived there, but because the conditions for preservation were not met. The silence in the record is not evidence of absence. It is only evidence of our ignorance, and so the spiral deepens, the layers of erasure compounding. By 50 million years after their fall, the continents have moved significantly. India, once an island, has collided with Asia, raising the Himalayas. The Atlantic Ocean has widened by 500 kilometers. Their coastal cities, built on continental shelves, the most desirable real estate, close to trade routes and resources, have been dragged down into the subduction zones where the oceanic plates dive beneath the continents. The magma melts their skyscrapers, their cars, their monuments, reducing them to their constituent atoms. They are recycled into fresh lava, erupting from volcanoes thousands of kilometers away to form new land. The atoms that once made up their greatest poets, their scientists, their lovers, are now part of a mountain range in a world that doesn't remember their names, doesn't even suspect they existed. At 100 million years, the map is unrecognizable. A new ocean, born from a rift that split a supercontinent, separates lands they once connected with suspension bridges and undersea tunnels. New mountain ranges, thrust up by the relentless collision of tectonic plates, block the winds, altering weather patterns, creating deserts where forests once stood. A new dominant species, mammals perhaps small and quick, thriving in the ecological niches left vacant by the extinction of the dinosaurs, scurries through the undergrowth, completely unaware that they are walking on the dust of giants, that the very soil beneath their feet contains the transmuted remains of a civilization that once reached for the stars. This would mean that the Earth is not a linear story of progress, not an arrow pointing ever upward from simplicity to complexity. It is a cycle, a loop, a wheel that turns through the ages. Intelligence rises, builds, overreaches, and falls. The Earth heals, patient and implacable. It buries the evidence under new layers of sediment, new forests, new oceans. And then, millions of years later, when the conditions are right, it tries again. Life experiments with intelligence once more, offering another species the gift and curse of self-awareness, the ability to shape the world and wonder about the cosmos. The dinosaurs in this narrative might have been the second attempt at sapience, or perhaps the 10th or the 100th. We might be the third. Or we might be much farther along in the cycle than we dare imagine. The silence of the universe, the Fermi paradox that haunts SETI researchers, the absence of radio signals, the lack of visible megastructures, the eerie quiet of the galaxy, might not be because life is rare or intelligence improbable. It might be because civilizations are fleeting sparks in an infinite night, brief candles that flare and gutter out, leaving nothing behind but a thin layer of compressed carbon and a few anomalous isotopes that no one thinks to question. But the story doesn't end there. It never ends. If this cycle is real, if the Earth is indeed a testing ground for intelligence, then we are not special. We are not the culmination of creation, not the chosen ones, not the final chapter. We are just the current tenants, temporary occupants of a planet that has hosted others before us and will host others after we are gone. And one day, perhaps sooner than we think, we too will be the anomaly in the rock. We too will be the thin layer of strange carbon, the spike in plutonium, the band of microplastics that confuses a geologist 50 million years from now. They will drill through the strata, extract a core sample and hold it up to the light. They will see the layer that marks the Anthropocene, the plastics, the radiation, the carbon spike, and they will ask the same question we are asking now. Was this a volcano, or was it something else? Was this nature, or was it them? And perhaps, if they are wise, they will pause. They will look at that layer with the same wonder and unease we feel when we contemplate the PETM or the Oklo reactor. And perhaps they will realize, as we are beginning to realize, that the Earth holds more secrets than we can imagine. That deep time is not empty. That silence is not the same as nothingness. That the past is not a dead thing, but a living question, waiting patiently for us to ask it. Let us step into a dream now, a vision woven from the threads of possibility and wonder. A vision of an alternate present, where the Silurian hypothesis has moved from theory to proven fact, where the whispered question has become a deafening answer that echoes through every hall of science and philosophy. Imagine that tomorrow, in the early morning light, a geological survey team in the Deccan Traps of India, a massive volcanic province formed 66 million years ago during the great extinction that ended the reign of the dinosaurs, drills a core sample that changes everything we thought we knew about our place in the universe. They are looking for basalt flows, studying the volcanic layers that poured out like blood from a wounded planet, trying to understand the timing of the eruptions and their role in the mass extinction. The drill bites deep, pulling up cylinder after cylinder of dark, fine-grained rock. The geologists are tired, methodical, expecting nothing unusual. And then, at a depth of 450 meters, sandwiched precisely between two layers of lava that bracket the Cretaceous-Paleogene boundary, they find something that defies all explanation. It is a thin seam, barely 3 centimeters thick, compressed and dark, running horizontally through the core like a scar through flesh. At first glance, it resembles coal, the compressed remnants of ancient forests. But this is wrong. There are no coal seams in basalt. Coal forms in swamps, in low-energy environments where organic matter accumulates over millions of years. This is a volcanic landscape, a place of fire and rapid burial. The team sends samples to laboratories around the world, and what comes back changes history. It is not coal, it is not shale, it is a fused, the synthetic composite of carbon and polymer chains pressed into a diamond-hard layer by 66 million years of pressure and heat. The molecular structure is unlike anything found in nature. Long-chain hydrocarbons bonded in regular, repeating patterns that speak of deliberate synthesis of industrial chemistry. Embedded within this black seam, like stars in a dark sky, are microscopic spheres of pure gold, platinum and rare earth elements, neodymium, yttrium, dysprosium, refined to a purity of 99.99%, a level of refinement that nature never achieves, that requires smelting, electrolysis, precise control of temperature and atmosphere. The scientific response is immediate and visceral skepticism. Contamination, the peer reviewers cry, their pens slashing through the manuscript. A hoax, a misidentification, a modern pollution that has somehow infiltrated the sample. The lead geologist, Dr. Sharma, defends her findings with the quiet determination of someone who has seen the impossible and knows it to be true. She orders independent dating of the layers above and below the seam. The results are absolute, confirmed by 3 separate laboratories using radiometric dating of the volcanic minerals. The basalt above the seam, 65.5 million years old. The basalt below, 66.2 million years old. This layer, this synthetic seam, was laid down in the final days of the Cretaceous, in the last breath of the dinosaurs' world, just before the asteroid struck the Yucatan Peninsula and ended an era. Further analysis by mass spectrometry reveals something even more disturbing: the isotope signature of localized nuclear fission. The ratio of uranium isotopes is skewed, showing clear evidence of neutron capture and decay chains that only occur in the presence of sustained nuclear reactions. There are trace amounts of technetium-99, an element that does not occur naturally on Earth. It must be created in reactors or accelerators, and it has a half-life of 211,000 years. After 66 million years, only the faintest whisper remains. But it is there, unmistakable in the data. Someone was here. Someone built, refined, split the atom and then vanished, leaving only this thin black line in the rock as their epitaph. The news breaks slowly at first, a ripple in the scientific journals, a murmur at conferences. Then it explodes, crashes over the world like a tidal wave, drowning every other story, every other concern. We are not the first. Nor the phrase is repeated in 1,000 languages, whispered in awe and terror. The history books, those confident narratives of progress from simple to complex, are revealed as fairy tales, comforting fictions we told ourselves to feel special. They are rewritten overnight, or rather, they are left blank because we do not know what to write. The museums are emptied of their certainty. The exhibits of human evolution, the triumphant march from Australopithecus to Homo sapiens, are suddenly dwarfed by the enormous, terrifying blank space of the 66 million years that came before. We call them the Precursors because we need a name, something to hold on to in the vertigo of this new reality. We do not know what they looked like. We have no bones, no sculptures, no images carved in stone. Only their shadow remains. I pressed into the chemistry of the rocks like a fingerprint on ancient glass. Some scientists propose that they might have been a branch of the troodontids, those clever, large-eyed dinosaurs whose fossils suggest a brain capacity approaching that of modern birds. Others argue for a completely unknown lineage, something that left no fossils at all, something whose very biology was so different from ours that preservation was impossible. In this alternate reality, our entire understanding of the Earth transforms, shifts like the ground beneath our feet in an earthquake. We realize with a cold clarity that the planet has hosted intelligence before. The Earth is not a virgin canvas on which we are the first to paint. It is a palimpsest, a manuscript that has been written on, erased, and written on again countless times. The great filter of the Fermi paradox, that mysterious barrier that seems to prevent civilizations from reaching the stars, the reason we see no aliens, no radio signals, no megastructures in the sky, is suddenly terrifyingly clear. It is not out there, it is here. Civilizations rise, yes, but they are self-limiting. They burn bright and burn out, victims of their own success, their own appetite, their own inability to live within the limits of a finite world. The Earth is not a cradle, it is a graveyard, a vast cemetery of ambitions, and we are walking among the tombstones without knowing it. Philosophy shifts, lurches, tries to find its footing in this new landscape. The great religions, those systems of meaning that placed humanity at the center of creation, at the apex of God's plan, must adapt or crumble. Some embrace a new theology of cycles, of eternal return, seeing the hand of the divine in the recurring experiments of intelligence. We are not the climax of the story. We are a verse in a long song, a stanza in an epic poem that has been recited since the first photons of sunlight struck the first green cells. Others retreat into fundamentalism, denying the evidence, clinging to the old certainties. But for many, the world expands, becomes richer, more mysterious. We are part of something larger than ourselves, larger even than our species. We are heirs to a tradition of consciousness that stretches back into the unimaginable depths of time. Science turns its eyes downward, abandons the search for signals from the stars, and begins to excavate the past with renewed urgency. We stop looking for Atlantis in the Mediterranean and start analyzing trace elements in the Permian strata, searching for the chemical fingerprints of the civilization that might have existed 250 million years ago before the Great Dying. We drill cores in the Arctic permafrost, looking for frozen evidence. We scan the ocean floor with magnetometers, searching for the magnetic anomalies that might mark ancient smelters or power plants, long since buried under kilometers of sediment. We start looking for the others, and the search consumes us. Who were they, these precursors? In this dream, in this vision of an alternate Earth, perhaps they were reptilian, descended from the quick, intelligent troodontids that stalked the undergrowth of Cretaceous forests. Imagine them, the saurians, we call them, for lack of a better name, were standing upright on powerful hind legs, their forelimbs freed for manipulation, for grasping tools, for writing symbols in the sand. Their scales iridescent in the Cretaceous sun, reflecting the light in patterns that might have served as communication, as art, as identity. Their eyes large and forward-facing, capable of stereoscopic vision, of depth perception, of seeing the world in 3 dimensions. They did not build with steel, did not mine iron and forge it in furnaces like we do. Instead, they grew their structures, cultivating bioceramics from genetically modified corals and mollusks, shaping living architecture that grew and healed itself, that breathed and regulated temperature. They powered their cities not with fossil fuels, but with geothermal energy, drilling 10 kilometers deep into the crust to tap the heat of the mantle. Their towers rose not from concrete and rebar, but from woven fibers of carbon nanotubes extracted from the atmosphere, spun into cables stronger than any metal. They were a civilization of harmony, perhaps, living in balance with the ecosystems around them, farming the algae blooms, shepherding herds of herbivorous dinosaurs the way we shepherd cattle. Or perhaps they were a civilization of brutal efficiency, strip mining the continents, burning everything they could find, racing toward collapse in a fever of consumption. We will never know. The moral arc of their history is as lost as their faces. Their accomplishments are lost to time, dissolved in the acid rain of millions of years, crushed beneath the weight of mountains that rose and fell after they were gone. Did they write poetry, compose verses about the sea and the stars, about love and loss and the passage of time? Did they have philosophers who debated the nature of consciousness, who wondered about the meaning of existence? Did they compose symphonies that would make us weep if we could hear them, melodies played on instruments we cannot imagine, harmonies that resonated with their alien sensory systems? Did they look at the moon hanging in their night sky and name it, give it a word that meant beauty or longing or home? We will never know. Their libraries, if they had libraries, have been subducted into trenches, melted in the fire of the mantle. Their music, if they had music, has faded into the background radiation of the Earth, indistinguishable from the hiss of entropy. All that remains is the layer, that thin black seam in the volcanic rock. The Saurian horizon, as the geologists now call it, was spoken with a mixture of awe and dread. Perhaps they too wondered if they were first. Perhaps their own geologists, their own seekers of deep time, drilled into the Carboniferous coal and found anomalies, layers that did not fit, isotope ratios that suggested intervention, refinement, intelligence. Perhaps they found evidence of an amphibian civilization that rose 300 million years ago in the vast swamps of the Paleozoic, a culture of beings that lived half in water and half on land, that built cities of coral and kelp in the shallow seas, that lasted for 100,000 years before a climate shift dried their world and erased them. Perhaps the Saurians found a layer of fused silica, the remnant of nuclear fire, and asked the same questions we are asking now. Perhaps they realized they were not first, and the knowledge humbled them, terrified them, or inspired them. A chain of question marks stretching back through the geological column, back to the origin of complex life, back to the moment when the first neuron fired and something in the universe became aware of itself. In this world, this alternate present where the veil has been lifted, we walk with a new humility, a new sense of our place in the order of things. We look at the birds, the sparrows pecking at breadcrumbs, the eagles soaring on thermals, the last surviving dinosaurs, and we wonder if their ancestors, 66 million years ago, once held the keys to the atom, once debated ethics and mortality, once looked up at the stars and dreamed of going there. We look at the octopus in the aquarium, its 8 arms exploring the glass, its large, intelligent eyes watching us with what might be curiosity, and we wonder if its lineage, or something like it, once ruled the Silurian seas with an underwater empire of glass domes and pressure-resistant architecture, a civilization that thrived in the eternal darkness of the abyss, beyond the reach of our fossilizing sediments. The world becomes magical again, not in the sense of fantasy, but in the sense of mystery restored. It is filled with ghosts, with the echoes of minds we will never meet, with the possibility that every stone we turn over might hold a secret. The sun sets over this alternate Earth, sinking slowly toward the horizon, painting the sky in shades of amber and rose. It is the same sun that shone on them, on the Saurians, on whatever came before them. The same nuclear furnace that has burned for 4.6 billion years, fusing hydrogen into helium, pouring light and warmth onto this small blue world. The stars begin to appear, pinpricks of light in the deepening blue. They are different from the stars the Saurians saw, shifted by the rotation of the galaxy, by the slow wheel of the cosmos. In 66 million years, the sky has changed, constellations have drifted, but the feeling of looking up, of craning your neck and staring into infinity, is the same. It is a sense of smallness, of insignificance in the face of the vast, but also a sense of connection, a thread that runs through time, connecting us to them, to all who have ever looked up and wondered. We are part of a lineage of dreamers, separated by chasms of time so vast they dwarf the imagination, but united by the same planet, the same carbon chemistry, the same water that cycles from ocean to cloud to rain. We're united by the same tragic, beautiful arc, rising from the mud, from the simple replication of molecules to complexity, to awareness, to the ability to look back and ask where we came from. And then, perhaps inevitably, falling back into the silence, into the long forgetting, making room for the next experiment, the next attempt. We touch the sky, briefly, brilliantly, and then we are gone. And the Earth turns, patient and eternal, waiting for the next species, the next question, the next dream. And now we return to the quiet, to the stillness of the present moment, to the solid ground beneath your feet, to the breath moving slowly in and out of your lungs. We have traveled far, impossibly far, from the warm, shallow seas of the Silurian to the nuclear fires of the theoretical past, through alternate realities and distant timescapes. And now back to the uncertainty of today, to this singular point in the river of time where you exist, where consciousness flickers in the darkness like a candle flame. The images begin to fade now, gently dissolving like morning mist under the rising sun. The sea scorpions return to the silt from which we summoned them, folding back into the sediment, becoming stone once more. The Saurian cities, those towers of bioceramic and carbon nanotube, crumble into dust in the theater of the mind, their foundations eroded by the patient work of imagination's reverse. We are left only with the Earth, solid and real, spinning silently through the void, carrying its cargo of stories told and untold. The nature of time is a mystery we live within but never fully grasp. It is a river that flows only one way, carrying everything with it into the dark, mountains into sand, forests into coal, civilizations into mythology, and mythology into silence. We cannot step into the same moment twice. The past is gone, irretrievable except through the fragmentary echoes preserved in rock and ice and the slowly decaying atoms of radioactive elements. Memory is the only thing that swims upstream, fighting against the current, trying to reconstruct what was from the few clues that remain. And our memory, both individual and collective, is tragically short. A human lifetime is less than 100 years. Recorded history stretches back perhaps 5,000 years, but the Earth has been here for 4.5 billion years. We remember less than 1/10,000,000th of its story. The rest is guesswork, inference, faith in the patterns we think we see. The Earth, in its patient way, is a recurring experiment. It does not care for our names or our borders, our languages or our laws. It does not distinguish between species. It cares only for life, for the self-replicating chemistry that drinks sunlight and builds complexity from simplicity. Life is the experiment. Intelligence, that strange emergent property where matter becomes aware of itself, may be a flower that blooms rarely in the garden of evolution. It opens its petals to the sun for a brief, glorious season, producing colors and scents that seem miraculous, and then it withers, its energy spent, its season over. But before it dies, it drops seeds into the soil, genetic memories, adaptations, possibilities that lie dormant, waiting for the next spring, which may come millions of years hence, when the conditions are again favorable, when the climate is right, when the ecological niches have opened once more. How many times has this happened? How many springs has the Earth seen? How many intelligences have bloomed and faded, leaving only the faintest traces, or perhaps no traces at all? We may never know. The humbling, vertiginous reality is that deep time swallows certainty whole. It digests confidence and leaves only questions. We build our monuments of stone, carving the names of kings and conquerors, believing they will last forever, that future generations will read them and remember. We write our books, archive our films, store our data in underground bunkers, believing they will be read by the future, that our thoughts will echo down the centuries. But the wind and the rain and the frost that cracks the stone and the roots that pry apart the walls and the tectonic slow-motion collision of continents that folds mountains and grinds the ocean floor back into the mantle. These forces are patient, endlessly patient. They have all the time in the world, literally. They are the world, and they will outlast every word we write, every image we save, every monument we raise. Perhaps this is the pattern, the recurring theme in the symphony of life. Each species that achieves self-awareness believes itself unique, special, chosen. Each civilization believes it is the apex, the culmination of all that came before, the final chapter in the story of progress. The Egyptians believed it, the Romans believed it, the medieval Christians believed it, the Enlightenment rationalists believed it, and we believe it now. We look at our technology, our science, our ability to split atoms and decode genomes and send robots to distant planets, and we think, this is it. We have arrived. We are the ones who finally figured it all out. And perhaps that belief is necessary, even essential. Perhaps we need that confidence to function, to build, to discover, to push forward. Perhaps humility would paralyze us, make us question every action, doubt every step. Perhaps belief in our own significance is the fuel that drives us to live, to strive, to care about the future. But the rocks beneath us, those silent witnesses, hold secrets we do not have the tools to see. They hold the compressed layers of millions of years, each stratum a page in a book we can barely read. They hold the silence of the billions who came before, not just humans, but all living things, the trillions of bacteria that thrived in the Archean seas, the trilobites that scuttled across the Cambrian seabed, the giant ferns of the Carboniferous swamps, the dinosaurs that ruled for 160 million years, longer than any mammal has yet endured. And perhaps hidden in the chemical noise, in the isotopic anomalies we attribute to volcanism or meteor impacts, are the traces of others like us, builders, thinkers, dreamers, who came and went, leaving only the faintest signature, a whisper in the stone that we have not yet learned to hear. What if the greatest discovery waiting for us is not in the stars, in the search for radio signals from distant civilizations, in the analysis of exoplanet atmospheres for biosignatures, but in the stones beneath our feet? What if the answer to "Are we alone?" is not no, they are out there, but no, they were here long before us? What if we are walking every day, unknowingly, reverently, over the compressed remains of those who came before? Entire civilizations reduced to a thin layer of carbon, their cities melted and scattered, their bones dissolved, their art and literature erased by the grinding wheels of tectonics? What if they asked the same questions we are asking now, looked up at the same stars we see, though shifted, drifted, aged by millions of years, wondered if they too were alone in the universe, if they were the first, if they would be the last? The Earth keeps its secrets well, locked in stone and ice, guarded by the sheer immensity of time. We are like children standing at the edge of an ocean, picking up shells on the beach, thinking we understand the sea because we can hear it in the shell. But the ocean is vast and deep, and we have only waded in the shallows. The deep past is an ocean we have barely begun to sound, a darkness we have barely begun to illuminate. We have drilled cores and dated rocks and built theories that seem robust, and they are the best we have, the finest tools our minds have yet forged. But they are incomplete. There are gaps in the record, missing chapters, blank pages, and in those gaps, anything might have happened. And as you drift now towards sleep, as your breathing slows and your heartbeat settles into its nocturnal rhythm, as the thoughts that filled your mind begin to dissolve and scatter like clouds before the wind, take with you this knowledge. Time is longer than we imagine, deeper than we know, and filled with more mysteries than we have words to name. The universe is older than we can truly comprehend. 13.8 billion years since the Big Bang, 4.5 billion years since the Earth coalesced from the solar nebula, 3.8 billion years since the first life emerged, 541 million years since complex animals burst onto the scene in the Cambrian explosion. And in all that time, in all those billions of years, how many experiments has the universe run? How many different ways has matter tried to know itself? You are one of those experiments, a way the universe has found to look at itself, to ask questions, to wonder. You are made of stardust, Literally, your body composed of atoms forged in the nuclear furnaces of stars that exploded billions of years ago, scattering their material into space, where it eventually clumped together to form this planet and everything on it, including you. You are ancient and new at the same time, a temporary arrangement of very old atoms, a pattern that persists for a few decades before dissolving back into the cycles of matter and energy. And so were they, if they existed. The precursors, the saurians, the hypothetical others, they were also stardust, also temporary patterns, also experiments in consciousness. The silence of the geological record is not the silence of emptiness. It is not the absence of story, but the presence of mystery. It is the quiet that invites questions, that beckons us to look deeper, to wonder more, to hold our certainties lightly and our curiosities close. It is the kind of silence that is full, pregnant with possibility, heavy with untold tales. Listen to it now, and as you let go of wakefulness, as you descend into the gentle darkness of sleep. Listen to the silence beneath the noise, the stillness beneath the motion. It is the sound of deep time, of the earth turning on its axis, of tectonic plates sliding millimeter by millimeter, of mountains rising so slowly you could watch for a lifetime and never see them move, of oceans evaporating and reforming over hundreds of millions of years. The Silurian Hypothesis, in the end, is not a claim but a question. It does not assert that there was a civilization before us, but asks, could there have been? And more importantly, would we know? It is a thought experiment, a way of testing the limits of our knowledge, of probing the boundaries of what we can detect and what we cannot. It reminds us that science is not a collection of certainties, but a method of asking questions and being willing to accept answers that make us uncomfortable, that challenge our assumptions, that force us to see the world anew. It is a hymn to humility, a recognition that we are small and time is large, and the universe cares nothing for our ego. Perhaps there were others, perhaps there were not. Perhaps we will find definitive proof one day, a layer that cannot be explained away, a signature so clear and artificial that it demands a new history be written. Or perhaps we will never find proof and the question will remain open, an unanswerable mystery that follows us into the future, a ghost at the edge of our understanding. Either way, the asking changes us. The wondering transforms us. It makes us more curious, more humble, and more aware of the vastness that surrounds us and the mysteries that permeate every layer of reality. Close your eyes now, if they are not already closed. Let your body relax completely, sinking into the support beneath you, feeling the pull of gravity, that ancient force that has held the earth together for billions of years, that holds you to this spinning ball of rock and water and life. Feel yourself connected to it all, to the atoms in your body that were once inside stars, to the water in your cells that has cycled through clouds and rivers and ancient oceans, to the oxygen you breathe that was produced by cyanobacteria 3 billion years ago and has been recycled ever since. You are part of a vast, interconnected web of existence that stretches back to the origin of the planet and forward into an unknowable future. The Earth keeps its secrets well. It buries them under layers of stone, under oceans of time, under the weight of forgetting. But it also gives us clues if we know where to look, if we ask the right questions, if we are patient and persistent and willing to be surprised. The deep past is not a closed book. It is an open question. It is an invitation to wonder, to explore, to imagine. And perhaps, in the act of wondering, we honor those who came before, whether they existed or not. We honor the possibility of mind in the universe, the miracle of consciousness, the brief, brilliant flame of awareness that ignites and then fades, leaving only light in its wake. And as you drift now, fully, completely, into the soft embrace of sleep, carry this with you into your dreams, that you are not separate from the earth, but part of it. Or you are made of it, sustained by it, will one day return to it. You are a way the Earth has devised to know itself, to think about its own history, to wonder about its own future. And if there were others before you, they were the same. Temporary, beautiful, significant in their own time, and then gone, dissolved back into the cycles from which they arose. The Earth continues, time flows on, and somewhere, perhaps millions of years from now, another mind will look at the rocks and wonder about us, about what we were, about whether we knew we were part of something larger, something ancient, something that will continue long after our light has faded. The Earth keeps its secrets well. The deep past is an ocean we have barely begun to sound. And as you drift now towards sleep, know that time is longer than we imagine, deeper than we know, and filled with more mysteries than we have words to name. And whenever you're ready to explore another world, we'll be here.